don't remember how to do this. What do I usually... Hello?
Talk into the mic.
There we are.
Point your mouth at the mic and just pretend that we were at the pub grabbing a pint. And whose round is it?
It's going to take a lot of imagination these days.
From ScienceSortOf.com, you're listening to Science Sort of.
Science Sort of. You're listening to episode 337. I'm your host, Ryan, and joining me to talk about things that are science, things that are sort of science, and things that wish they were science, it's Dr. Patrick Wheatley. Patrick.
Yes.
This episode, we are featuring an interview I did with Carl Zimmer.
Oh, man. Heavy hitter.
Yeah, we've had Carl on the show before to talk about his previous book, She Has Her Mother's Laugh, which was all about sort of an exploration of genetics and what does it mean that we pass our genes on to the next generation, which is a lot more complicated than I would have thought. and in this book, you would think though, if you've explored that, you've sort of explored what it means to be alive, but Carl felt that the more he looked into these topics, that the actual what is life was a question that was not yet answered sufficiently for him. And so he wrote a whole other book about it.
I mean, sure, that's... I wish I had that kind of ambition and drive.
Right. Well, and I mean, I think one of the things that we learn in the book is that when you actually work as a biologist, the fundamental philosophical question of what life is may not be super relevant to you just doing your job every day, but it's important for us all to have a framework around which we agree what is and isn't life, right? So, really great conversation with Carl. We're going to play the first half of our chat now, and then Patrick and I will be back in a moment to talk about some drinks. See you in the next segment. Zimmer, who is one of the most sought after and celebrated science writers, recently praised in New York Magazine as the country's most respected science journalist. He was previously on the show to talk with Kelly and myself about She Has Her Mother's Laugh, which was named the best science book of the year by The Guardian and won a number of other awards as well. He's here today to talk to us about Life's Edge, the search for what it means to be alive, which is on sale now wherever fine books are sold. Carl, thank you for joining us.
Thank you for having me again.
Yes, I'm very excited. Man, I really enjoyed this book. I'm a biologist / geologist / paleontologist by training, and I learned a ton. So I think if that can be said for a great win in my book, is that like if there's a book that's sort of about the topics that I already know somewhat intimately, that I learned so much from your book is just a huge, awesome thing. So thank you.
You're most welcome.
This book is in many ways about the genesis of life, but also the genesis of our ideas about life. I know the word genesis is a little loaded, but I'm referring to it in just the term of it in origin. Can you tell us a little bit about the genesis of you having the idea to do this book in the first place? What sort of prompted you to explore this topic?
I've been writing about biology for a long, long time, whether it's jellyfish or dinosaurs or killer bacteria. And what's interesting is that, I just would sort of take it as a given that all these things are alive, that we call them life. But it always perplexed me that scientists would have such a hard time agreeing amongst themselves on what the definition of life is. And it seemed like it would be as weird as chemists not agreeing on what a molecule is. And yet, the more I would look into it, the deeper the problem became. But it's an interesting problem, Mm-hmm. Like it's like the fact that it's so hard to make a concise, agreed upon definition of life and to draw sharp edges around life is it's a paradox of the most interesting sort. And I just got pulled deeper and deeper into it, and just decided to write a book about, centuries of effort of trying to draw that line, to find that place where the living world meets the non-living world. And in a way, it's a book about, sort of an ongoing failure, but a really interesting failure.
Yes, that is actually a point I wanted to bring up, because you talk about in this book how when we are taught the history of science, we're usually just taught a series of wins, right? But when you do science, you know that that's not how science works. Science is a more often than not a series of small failures that occasionally results in a win. But when you look at it historically, we tend to just sort of highlight the folks who got it right, or the folks who are celebrated for getting us to that next step in our thinking, the sort of paradigm shifters. But in this book, you talk a lot about the folks who were brilliant in their own ways at the time that they lived, but their ideas either didn't win out, or they just had another failing in their interpretation of the data around them. So can you talk a little bit about why you thought it was important to take sort of this deeper look at some of the ideas that didn't work?
Well, one of the things that's fascinating about these ideas is that these were not like odd little notions that somebody just scribbled in a notebook and didn't tell anyone. These would be ideas that would take the entire world by storm. And so, I actually start the book with a physicist in the early 1900s named John Butler Burke, who believed that he had created basically the simplest form of life possible from scratch, simply by mixing radium, the radioactive element, with sterilized beef broth at Cambridge. And I mean, his ideas were the stuff of headlines all over the world. He was flooded with letters. He would go give these lectures to huge audiences. And it really did seem that he had actually outdone Darwin. And then it very quickly became clear that he had gotten fooled by sort of just a fluke of chemistry in his procedures, and that he just had been so eager to seize that brass ring that he had, cut corners and not really held himself to the standards he should have. This happens a lot. It's actually really tricky and risky to be a scientist there at that sort of borderland between the living and the non-living worlds. Even now, people who work on the origin of life, they kind of know they're taking their scientific reputation in their own hands a bit, because the stakes are so high, and you can just be so very wrong.
Yeah, I think that's something you do a nice job of framing, is that you talk about people who study pythons versus people who study nerve cells, and those people all they're well away from the edges of the fuzzy boundary between life and unlife. They're all working, and we definitely know that pythons are alive. We definitely know that bats are alive, and so it sort of becomes a question philosophically that biologists don't really have to think about, because once you're fully ensconced within life, you're able to just operate with that system, and you don't have to really ask yourself the fundamental questions. It's like you said, it's once you get to those borderlands where things become fuzzy that it's really tricky, and it's oftentimes that then becomes not even a question of biology. It becomes all these other questions, including one of philosophy.
It does, and I ended up talking with several philosophers for the book, and scientists have a way of some scientists will denigrate philosophers as just getting in their way, but I think that in a situation like this, it really illustrates that unless you have a firm philosophical foundation for what you're doing, you can just end up in a real fog. And there are big stakes for this. I mean, it's not like a purely academic argument that would keep some freshmen up at late at night in their dorm. I mean, when NASA decides to spend a whole lot of money to go look for life elsewhere, what should they look for? Should they just look for Hollywood extras who are, with a little bit of makeup on them?
They wouldn't have to look far outside Caltech then, because I think they filmed some of those old Star Trek episodes in the hills not far from
Exactly. So, okay, all right. It doesn't have to walk on two legs. Okay, fine. But does it have to be made of cells? Does it Does it have to have DNA? Like, what would qualify for the discovery of life beyond Earth? You have to have an answer for that, or at least a working answer to make that search meaningful.
Yeah, and I've been attending the National Academies has been doing some really cool stuff on geoheritage. So sort of like, the heritage we all share with the geology under our feet. And one of those geologic resources that I'm particularly enamored with are fossils as a paleontologist. And I've always loved fossils even before I was a paleontologist. And a question that I brought up in one of the discussions I was having with some of these geoheritage experts who are doing really interesting stuff in the forms of both geoheritage and geoethics, so like making sure that people aren't messing up petroglyphs, or even making sure that people aren't messing up particularly stellar examples of different types of sedimentary structures out at field sites so that future students can come see them. And I posed the question, I was like, well, what does this mean for us, like sending probes to Mars that can actually drill into the subsurface? Like, do we need to be considering that when we're sending these vehicles, before we even send the people, or do we even need to be worried about like what we're potentially screwing up by even searching for life the way that we have been in the first place?
Sure. And, one of the most important things to do is to make sure that you're not contaminating the place you're trying to explore. So NASA puts a lot of effort into sterilizing their probes before they leave Earth and go to Mars. But it's kind of weird how it can be really hard to get rid of those very last bacteria that are clinging usually as spores to these probes. There seem to be some bacteria that really thrive in these so-called clean facilities at NASA, and so like NASA's done its best not to contaminate Mars with bacteria from our own planet. But if we do indeed appear to find life on Mars, let's first make sure that it didn't come from Southern California.
Right, and then that brings up, then you get into the whole thing of panspermia, and like if life came from Mars to Earth in the first place, and now it's just going back to Mars, are we just completing the circle? And it also made me like, I have such conflicted feelings about the probe that was sent to the moon full of tardigrades from Israel, and and you talk about it a little bit in the book, but it's like, well, hang on, we didn't, I know there's no way for us to come to a worldwide consensus on these matters, but like, shouldn't we have voted or something on like whether or not it was okay to send living things to the moon that could potentially come back to life if just add water? It's such mixed feelings on that mission, and then they crashed and we lost the probe, but the tardigrades could still be there. It's still ready to be brought back to life, and now we don't even know where they are. So I just have such mixed feelings about the whole thing.
It was a very strange endeavor. Yeah, it was just this. The idea was to send this library of life, they called it, to Mars, I guess, as a way of sort of saving some information about the planet. And they sent these tardigrades, and these tardigrades, for people who don't know about them, are sometimes called water bears or moss piglets. They're these little microscopic animals that clamber around on, I think 8 legs. And anyway, they are just, they really make a mockery of this sharp line between at the edge of life. Because if they get dehydrated or exposed to really harsh conditions, they go into what scientists themselves have called a third state of existence. They don't die. What happens is that as the water leaves their bodies, they replace the water with a sugar that kind of behaves like water, and then also certain proteins that can kind of form a glassy matrix around all of the structures inside their cells. So they basically vitrify themselves. They turn themselves into a kind of a protein glass. And everything is exactly where it was before, and just in perfect order. And so these things are, by some definitions, these things should be considered dead. They can't do chemistry. Like their proteins can't do anything. They're locked in place. But once they are exposed to some moisture, some water, they will basically swap the water back in, get rid of these glassy proteins, and poof, everything is back in order again. So they decided it would be interesting, I guess, to send tardigrades to the moon, and there they are. And I would argue unless they I would imagine that they're there in this third state, just waiting. Yeah, if someone came along and put them in a little pressurized atmosphere and added some water, I think they'd come back to life.
And that's sort of one of the things you talk about early in the book about how like one of the easiest ways to distinguish life from non-life is death. Like it can be hard to say when life starts. The sort of the origins of life are fuzzy, but it seems like the end of life should at least be clear. If you dehydrate a human, you cannot pour water on them and get them to come back. That's just not how it works. But our sort of anthropocentric view of that gets confounded by all these crazy examples that we see in nature. Another great one that I think, again, is eventually, it's going to come back to bite us. I don't know how, but is all these permafrost and glaciers that are thawing out, and we're finding seeds that never germinated tens of thousands of years ago when they were first frozen up in the soil or in the ice, and then we plant them and they grow. As if they just needed they were waiting for spring this whole time. It's absolutely incredible.
30,000 years later, they're ready for action. And it's not just seeds, there are plenty of microbes that have been preserved, and they're thawing out right now.
Well, when has a previously unencountered microscopic organism or virus ever caused a worldwide catastrophe that threw everything we knew for a loop? That seems very far-fetched. And I do have a question that's tangential to that, but I do want to talk a little bit about one thing I really love in your books. This is true for She Has Her Mother's Laugh and Life's Edge, is that you find these historical figures that, by and large, I've never heard of, but who are integral to the history of the science that I've spent my life studying. And so every time I see a new name in your book, I get a little excited because I'm like, oh, this is going to be like some brilliant but probably deeply flawed and at least highly quirky person who's going to have to deal with some problem or disease that ends up being fundamental to the science. How do you find out about these people? Like, how does your research lead you to all these wonderful historical figures that you then get to share with everyone in your books?
Well, the people who spend their careers as historians of science do us all incredible service by digging deep into, the series of events and the experiences that make up scientific history. And, I'm trying to sort of follow their example of trying to show everybody that the history of science, like history in general, is not just a sparse timeline of a few people we've agreed are superheroes. It's much more complicated and interesting than that. And, the people who might have been in a way like visionaries and be doing work that seems very relevant now, 100, 200, 300 years ago, at the time might have been just intolerable crackpots and made a lot of mistakes themselves and were just flawed people. But, they, in a way, like what they're doing and kind of illuminates sort of how our overall thinking about these things evolves and changes. So, what John Butler Burke was doing, trying to make something come to life with radium and beet broth. I mean, you can say like, well, that's ridiculous. How could that would never have worked? That was crazy. But, on the other hand, everybody thought that radium had a mystical, almost vitalistic, life-giving property. I mean, people really thought that, that radioactivity in general and radium in particular was good for you. So, he was in a way tapping into that. And now you look at what happens, what's happening now. Well, there are actually people who are trying to create artificial life, protocells that have primitive genetic molecules inside of them that might be able to someday, replicate and grow and so on. They're part of Burke's tradition, but nobody knows who Burke is because he flamed out, because it was such a spectacular failure. And yet there's something really meaningful in those sorts of stories.
And I think his story and a lot of the stories you tell, one of the most telling moments in the narrative of each of these people, and I'd be interested to hear more about how you think about framing these narratives, but there's a point at which usually these people get challenged, right? And the way that they respond to the challenge is sometimes, most of the time, they double down. Most of the time, they dig in their heels and say, no, this thing I've discovered is right. Burke certainly did that, led to him basically being ousted from the scientific establishment. And I think anyone who's been to grad school has met the older professors in the department who maybe tend to do the same thing. And that's one of the reasons I thought the story of Huxley was so powerful, because Huxley was actually a figure that I'd known about and always had some affection for as Darwin's bulldog. I'm talking about Thomas Huxley, not Aldous Huxley. And I just thought the way he responded to finding out he was wrong after a career of promoting this idea, his Bathius, I'm not sure if I'm saying that right.
Bathybius.
Bathybius. The way he responded to that, I was like, oh man, this guy actually does kind of get to end the story as a hero, even though he was wrong. And I don't know. I think I'm always a little nervous learning new info about historical figures I used to admire, just because I think we've seen in the modern era how that can lead you astray. But I thought that was really cool. I didn't know how much you knew about Huxley before this, and what you kind of thought of how he handled what could have been his life's great disappointment.
Yeah. So this was an aspect of Huxley's life that I really didn't know about. I will admit, I'd never heard of Bathybius before I worked on this book. I thought I knew Huxley pretty well because, I wrote, a book early in my career called Evolution: The Triumph of an Idea, where I have a lot in there about Darwin and his allies and how the theory of evolution, emerged and won the day. So obviously Huxley's central to that. And there, you look at him as being on the quote unquote winning side, but he also came to believe that the entire ocean floor was carpeted with what was called a living paste, a mass of protoplasm that was like a single organism that he gave a name to. He called it Bathybius. And he had gotten hold of specimens from the deep sea, just sediment, and was analyzing it, and was thought that he was seeing a sort of a strange sort of blobby mass of protoplasm. And this fit in with ideas at the time that protoplasm, which was the name they gave for the stuff inside of cells, was like the fundamental stuff of life. Whatever made life different from everything else, it had to do with protoplasm somehow. They didn't know the DNA was in protoplasm. There was just this almost mystical goo. And in the early 19th century, some romantic German philosopher named Oken had actually speculated that there was something he called the Ur-slime. So you think of the proto-slime from which all life began. And now Huxley's like, I found it. And it's here. It's everywhere. Because these cruises will go out and they would bring stuff back, and he'd be like, yep, they've got it too. They've got it too. These are the early voyages. We're finally starting to scoop up stuff from the surface of the deep ocean, the deep ocean floor.
Right. At a time when it was really relevant, because we were starting to lay down telegraph lines between England and Europe and the Americas. And so knowing what was down there was also important for this technological innovation that was trying to be put out there.
Exactly. If you're going to lay a cable down that's going to connect, the United States and the United Kingdom, you want to make sure it's not going to just sink down into the ooze. So you want to know what's down there. And so Huxley was very excited that he felt like he was finding where all life on Earth might have begun. And he made big lectures about this and about the importance of protoplasm and all the rest. I mean, he went in deep with Bathybius. And then, there were then this really impressive scientific voyage of the ship, the Challenger, went out. It was fitted out with it was like the Apollo mission of its day. They were just fitted out with all the best scientific equipment and a whole team of scientists. And they just were going to go around the world and study the ocean. And one of their top priorities was Bathybius. We are going to get the best Bathybius samples there are. And they were actually studying it and preparing their stuff on the ship. They weren't sending it back to England for study. And they just kind of got a weird feeling. They're like, we're not finding it. This is not working out. And actually they noticed that in some conditions, when they were storing their stuff away, a film would form in the sediment, and that looked a lot like what people said Bathybius was. And eventually they just decided we got to send Huxley a letter. We have some very bad news. So they sent him a letter and laid it all out. And as you say, Huxley could have doubled down. He could have been like, no, I'm absolutely right. This is how I explain the world. Instead, he immediately sent that letter on to Nature, the journal, with a little note just saying essentially saying, if there's a mistake here, I'm the one who made it. And that was that. He just owned up to it. And so, we remember Huxley fondly. And in his, these huge obituaries when he died, they talked about all the different things that he studied. No one ever mentions Bathybius, which, in 1868, when he was proposing it, should have been like his greatest discovery. But it was an illusion. It was a mirage.
And just that he owned it was such a baller move that I was really, I felt good about him still after reading that passage.
He was fearless. He was fearless going up against the opponents of evolution, and he was fearless to say, "Wow, I really screwed up, didn't I?"
Well, yeah, and I loved his quote. There was a counter, some noble person who kind of didn't like him and said something about how like, well, he got this big thing wrong, and Huxley's response was more or less, yeah, the only reason I got it wrong is because I was trying to do something which you haven't done, so back off.
That's right. The quote is, the only people, scientific or other, who never make mistakes are those who do nothing.
Mm-hmm. It was like when people were going through and finding all of the typos and whatever in Dr. Biden's doctoral thesis, and like all of the people I know who have written dissertations on Twitter, myself included, had something to say along the lines of like, look, the only dissertation that gets published without errors is the one that does not get published. the only way for you to find a mistake is for us to have done the work in the first place. So.
Yep.
Well, it would not be an episode of Science Sort of if we didn't also talk about what we are drinking. You know what, Patrick? Before you tell me what you're having, I'm going to go first.
Okay.
I'm going to give you some hints and see if you can guess it. It is caffeine-free.
Okay.
0 sugar.
Okay.
Zero
Coke
calories.
With caffeine-free.
Seasonal, it says on the can. That's another hint.
Okay.
Have you figured it out yet?
I mean, it's seasonal? That's
seasonal.
throwing me.
Yeah, that was a weird one. I don't know why I told you that. 0 total fat, 0 sodium, 0
it's an Easter egg flavored seltzer.
Carbohydrates, 0 protein, not a significant source of anything, apparently. Keep cold for freshest flavor. It is cold, I can tell you that, in its can.
Okay.
I think, okay, I guess you're out of guesses. I will tell you. It's gluten-free. Whole30 approved, if you're familiar with what that is.
Well, I'm not.
It's a thing about like complete proteins or something. It has something to do with amino acids and essential versus non-essential amino acids, I think. It is a Hoplark sparkling hop tea, the sprucey one, made with spruce tips from Boulder, Colorado.
Interesting.
So Julie and I have been
Boulder.
exploring some non-alcoholic refreshments, which I know you are also into more and more these days, and so this is one I wanted to try, because one of the issues we're having is, this is completely clear. This is so weird. It's like Sprite. But it is hoppy. Here, let me see if Julie wants to try it. Hey, Julie, come try this. One of the issues we're having is that, like, the thing that Julie doesn't like about beer is hops, so when a thing is like, it's not beer, but it's also still hoppy, what good is that?
It's the worst of all possible universes.
That's not bad.
It's got a weird lychee kind of like.
It's spruce tips.
Okay, it's like lychee.
This is called the sprucey one.
In the sequel to Zootopia.
Drink that.
Julie would drink it. You can take it if you want. I got a half a can here.
I'll come back for it.
All right. This is actually much nicer and more refreshing than even I thought it would be. I wasn't sure if I was legitimately not sure if I was going to like this. I've seen a number of different hop teas out on the market. This is the first one I've tried, and this is legitimately quite refreshing.
Yeah, that's cool. I have not tried any hop teas, but maybe I will.
Yeah. What about you? What are you up to?
Yeah, so similar to you. So we're recording this on the anniversary of the UK's first lockdown. So about this time last year, we locked down, and I think all of Britain just ordered cases of wine delivered to here. I mean, you could hear it in like the recycling collections. It was just like bottle dump after bottle dump going down the street. So anyway, after a few months of that, I think we got a hold of ourselves and realized we weren't coming out of this anytime soon. It was time to cut back on that if we wanted to live a normal, productive life.
I mean, that seems kind of
so yeah, we
living a normal life, like, ugh.
Right. Well, maybe it's not normal, but I guess it's not normal. But anyway, definitely cut back on booze. I had some Guinness for St. Patrick's Day.
Me too.
I had one other drink, but really since 2021 kicked off, I've had very, very few.
It's weird.
Alcoholic beverages.
Can we talk about Guinness for a second? Because I literally had some leftover corned beef and potatoes for lunch.
Okay.
It's funny that like I'm old enough at this point in my life that like Guinness is now like a nostalgic beer for me because it's one of the first beers I drank much of, just because I went to Ireland when I was 18 and could legally drink it. And so like I had a lot of it in Ireland. And it's so funny to me that now when I have a Guinness here, obviously, you know, from the tap is better, as Charlie and I proved in our first ever special edition episode. but you know, I can't go get beers from taps easily these days. So I had it in the cans because I think the cans are preferable to the bottles. And it's funny that like I never, you know, I think nostalgia and childhood, I think like Ninja Turtles, right? I don't think like what beers I used to drink when I was young. Do you have that too? Is that like, am I talking out my arse?
I mean, I guess I have some nostalgia for it. I definitely have some. Yeah, I think nostalgia is an appropriate word, or close to an appropriate word for Guinness. I mean, it's one of those things that sort of instantly transports you to places you've had one.
Yeah, exactly. And it's not like it's a beer that I think it's one of the few beers that I still have regularly that I had a lot of earlier. Whereas like most of the time my beer consumption, I'm probably an extreme example of this. Because my beer consumption, it is rare for me to have a beer twice. Like, I am almost always looking for the beer that I've not tried before, and if there's a menu of a dozen options, and I've had 11 out of the 12, I'm going to order the 12th one without fail. You know, that's just my mode. That's what I do. So I think it's rare for me to have a beer that I go back to. Even some of the other beers I had in California, like I just can't get them as easily here in DC. And so maybe there were other beers that would be nostalgic for me, but that I just don't have access to like I have access to Guinness. I don't know. It was just a thought I had while I was drinking my Guinness and eating my corned beef.
Yeah.
Also one of the few times of the year Julie lets me buy a giant chunk of beef to cook. I traditionally corn my own beef brisket, and actually you're mentioning the anniversary of the lockdown. Last year's St. Patrick's Day was the last time that Abe actually was inside my apartment. Abe and Bev came over to have St. Patty's Day dinner with us, and I actually had bought a fresh beef brisket and corned it myself, which was really something I really enjoyed doing. I have the pink salt and everything. It takes
Hawaii.
No. It's not like pink lava salt. This is like a nitrate salt, potassium nitrate salt.
I see.
For
Gotcha.
curing salt, right? Yeah, it bonds with the myoglobin to competitively exclude oxygen, which prevents the meat from getting brown and gives it that pink color.
Little chemistry to go with your corned beef.
Yeah, and speaking of chemistry, what is life if not chemistry that's figured out how to replicate and evolve from a certain point of view? An emergent property.
I never actually got to drink my drink. Right?
Oh, all right. Well, go ahead. Get on with it. Oh, I guess I did. I absolutely cut you. I absolutely cut you off to talk about Guinness, and then suggested that you were the one wasting time. All right. Yeah, that's not fair of me. But please continue.
Where was I? Yeah. So we drank a lot earlier. A year ago. We've dialed it way back. Been experimenting with alcohol-free or, very nearly alcohol-free beers. And so I'm about to drink a beer from a brewery called BrewDog. And they're one of I guess they represent kind of the UK's microbrewery spirit, the way the US has taken microbrewing these days. Sort of BrewDog would maybe be something like a Sierra Nevada to,
they're in Scotland, right?
Are they? I don't know, Elon. It certainly sounds like they could be. Yeah, I'll bet they are, actually, because of the story that I'm getting to.
They were the ones that did the beer inside the taxidermy squirrel. Do you remember that one back in the day?
I don't remember that.
Okay. Then please continue then, because that's I will
made
avoid that tangent.
They brewed a beer called Tokyo a long time ago. It was a heavily, like a 12% alcohol stout, imperial stout. Then a few years later, they tried to make it even more alcoholic and then brewed Tokyo Star or Tokyo Asterisk. I don't know how you're supposed to pronounce it. And it was like 18% alcohol. And they kicked the hornet's nest when they did that, because there was all sorts of kickback about, and I think it was actually banned. It was definitely banned in Scotland. I think maybe it was banned in all the UK. So there was a lot of brouhaha about how heavily alcoholic that beer was. So in response, they brewed this non-alcoholic beer called Nanny State. And that's what I'm drinking right now. And I kind of dig the non-alcoholic beers. I think you and I have talked about how drinking and driving is much more heavily frowned upon here in the UK than it sort of is in the US. Even though the legal limits are similar, practically no one would drink, and at least no one I've encountered would. They might drink one, but usually they won't drink anything if they're driving.
Which is a good thing.
Yeah, I think it's to be commended. Anyway, cheers. And what were you saying about chemistry?
That chemistry is what happens while you're making other plans? Is that or something like that? No, life's what happens when you're making the other plan. We should talk more about what life is, and we're going to do that with Carl Zimmer in my second half of my chat with him, coming up right now. What would you say was the thing that surprised you most in researching this book, either from a historical perspective or a scientific perspective?
I have been surprised at just how much we're moving towards understanding the origin of life. We're still not there's a lot that's really fundamentally unsettled, like exactly where it happened on Earth, but the experiments are just getting to a level of sophistication that I just don't think that anybody really anticipated. So, there are people who are sort of simulating what it would have been like in a volcanic pond, for example, on the early Earth, and are showing how, like, in cycles of rain and drought, you could get sort of a process by which RNA, little pieces of RNA, the genetic molecule, could actually start to grow even before cells existed. You have scientists who are creating protocells that are, they're not, by no stretch of imagination would we look at them and say that they're alive, but they're able to do more and more, like process signals or hold on to genetic information. It's just hard to get them to do them all at once. But there are even scientists who are just, I read about one scientist, Leroy Hood, who has basically built a robot chemist that just day and night does chemistry, looking for combinations of very simple molecules that might produce droplets that act in a lifelike way. And they're getting kind of weird. I mean, they're like, you look at them and there's just some, depending on the recipe, they look like they're just like scrambling around like a bunch of puppies in a cage. I mean, you're like, what is this? So I think the other surprising thing is that, people may think that this is all just sort of people may think, well, this is interesting, but it has nothing to do with real life. But, the fact is that actually some interesting things do come of this work. They're quite practical in terms of applications. So one scientist who studies the origin of life named David Deemer, he was thinking about, well, okay, if you got a really simple proto-cell, like how is stuff going to get in and out? You can't just have a perfectly sealed shell because things have to get in and out for life to exist. We started thinking about, well, we started imagining like a simple pore and like, what if genetic material could go in and out of a pore? And he's like, wait a minute. If I run, say, DNA through just a single pore, like that's going to change the electric field inside the pore. And I could measure that. And if I measured that, I could actually like figure out the sequence of it. And so like as a total side project, he patents an idea for sequencing DNA. And, a couple of decades later, that's what's now known as nanopore sequencing, which is a really like versatile, very useful way to cheaply sequence DNA with a little thing that's like smaller than your iPhone. And that came about by someone thinking about the basics of life. And so I found those things incredibly interesting as well.
I also think it's, for people who aren't scientists or haven't spent a lot of time learning about how the process of science works, I think it's usually a surprise for folks to realize that most of actual science is just finding a way to measure something, like building a better ruler for the specific question you're trying to ask. Like, it's such an important part of the process that I don't think gets enough credit.
Yeah, and I think that, it's what's interesting in terms of measurement is that, I talked to one scientist, a physicist, actually at Caltech, Rob Phillips, who really thinks that we're kind of in a sort of a pre-Galileo period of studying life where, or pre-Newtonian maybe, where there are a lot of valuable measurements being made of living things. We're getting better and better at making measurements, and it's kind of like when people like Tycho Brahe just started like making really, really careful measurements of the planets and the stars. And after a while, those kinds of precise measurements start to add up. And then people can look at those measurements and see a bigger picture and come up with a theory, so that you can start to think about, theories about, forces like gravity in the case of looking at the stars and planets. So we may be in a sort of a phase where, we don't have an agreed on theory of life, but we might have one, as we make more and more of these measurements that might emerge.
Well, that actually brings up something I did want to ask you is, in having researched and written this book, do you now feel like you yourself within your own kind of mindscape have a better operative definition for what life is, or would you say you just have a clearer understanding of how fuzzy the boundary truly is, or a bit of both?
I mean, it is so spectacular how far the scientific community is from having a single definition of life. I mean, it's a little funny, I have to say. Scientists, there are literally hundreds of definitions out there on the books, and people keep coming up with new ones. It's not like the scientists are converging on them. And, when I was working on my book and I might be at a scientific meeting and I just introduce myself and say, I'm working on a book about, what it means to be alive, people say like, well, of course, the true definition of life is replication, or, the true definition of life is it all has to do with translation. And I'm like, but that guy over there, the one over there, like on the other side of this room, just told me something totally different, So I think that that tells us something about sort of the problematic nature of trying to define life. And that's where the philosophers come in. Ludwig Wittgenstein can tell you about games, for example, and why it is that you can't really actually define a game in a rigid way, but we all know what games are. So maybe life is like that. Or maybe like it's absurd to try to define life in 2021 as it would be for an alchemist in, say, 1500 to try to define water. Alchemists would say, I mean, you can even read Leonardo da Vinci, like writing about water, like, well, it's wet. It's transparent, like just this catalog of things like, well, if you fulfill all these criteria, then you're water. And that's not really that meaningful. What's meaningful is, 3 centuries later to have a theory of chemistry that says there's atoms and molecules, and water is made up of these things we call molecules that are made up of these particular kinds of atoms, and that lets you explore water rather than just trying to come up with a set of words to define it. But it makes me more optimistic that I think we will reach a theory of life with those measurements I was mentioning before. I mean, I'm really taken by the parallel with superconductivity. Just, it's a property of matter. And when it was first discovered in the early 1900s, people were like, whoa, that's weird. Why did this material, I believe it was mercury initially, why when you make it cold does the resistance just go away? What's happening here? And it wasn't something special to mercury. There were other materials that would go into superconductivity at a certain temperature, and it all seemed totally inexplicable and random. And it wasn't easy to explain. Einstein tried and failed. Feynman tried and failed. But then some other physicists came along and they had a better idea about what it does to the electrons in a material. And then now you have a theory, and now it makes sense. And not only that, but you can say anything that fulfills these properties could become superconductive. And we can now play around with materials to create, room temperature superconductivity. It empowers you. So on the one hand, this is a book about lots of failure, and we really are in the dark, but the light is coming, I think. I just don't know if we'll be alive to see it.
Yeah, it's failures in the service of progress, right? All these failures are part of the story of us making any forward movement at all, I think. And, I personally hope that if we can come up with a consistent theory of life, that we can also use that to then come up with a consistent definition of what a species is, because that's the one that always gets me in trouble with my own work, is the fact that this fundamental unit of biology is still tenuously defined and defined differently depending on the system that you're working in, which I find it's amazing that we can get anything done at all with us all kind of working with a different, when you see it version of a species.
Right. And that was before you discovered that everything was hybridizing and mixing everything up.
Oh yeah, and then you start arguing with folks about the fossil record, and well, we have no idea if they were hybridizing or not because they're all dead. So it's funny that I'm talking to you now because I'm actually doing another interview later this week, and so this interview is kind of be part of a two-part series with an author who's written a book on how Earth's biodiversity might inform our search for life on other planets. I know you touched on that a little bit, but can you talk a little bit more about where is your head currently at when it comes to astrobiology? Where should we be looking? What are we looking for? Are we anywhere close with our current efforts?
Well, I in Life's Edge, I talk about, being born as I was in 1966. It was at the moment to grow up as a kid and have really weird expectations about any day now we're going to find alien life. Humans went to the moon, and that was amazing and exciting. And then, well, what's next? Well, Mars is next, and Viking gets to Mars, and well, it's a little confusing. Well, what is there? And the instruments turn out to not really be up to the job of seeing if there was life there or not. And I don't know, I just was sort of in this holding pattern, well, okay, yeah, but then we're going to keep exploring and really getting to the bottom of the question of whether there's life elsewhere in the solar system, and just hasn't really moved very quickly, at least for my, impatient child self within me. But, this is going to be a project that's going to take a long, long time. And it's understandable that, NASA is, being conservative. It's expensive to go look for life. And so you go look at the planet next door. That's fine. Go look at Mars. But what are you looking for? Well, they're kind of looking for life just exactly like it is on Earth, cellular life with something like DNA. And okay, that's fine. But that really kind of constrains your possibilities.
Mm-hmm.
I would love it if, I write in the book about an astrobiologist named Laurie Barge, who's been really, in love with the frozen moons further out in the solar system, like Enceladus. There you've got a liquid ocean under a layer of ice and a lot of energy inside there because the tidal motion going around Saturn just keeps pumping it full of heat. So something amazing could be happening under the ice. Now, maybe there's life there. Maybe it's not like life as we know it, or maybe it's life in the process of being formed. Like I would love to be in that submarine that would go down there and check it out.
Mm-hmm.
But, maybe we need to be looking at, other solar systems, in which case we're going to need to look at their atmospheres. And again, like, just because you can't, tune in, their satellite TV channels or something doesn't necessarily mean there isn't life out there. So there, we may need like deeper theories of life. Like maybe there are certain kinds of molecules that take so many steps to assemble that if you see them, they have to be a sign of life. It doesn't, but it doesn't, and then you're not limited to saying like it has to be DNA life or even carbon-based life.
Right. It's one of my favorite things to think about, just because who knows where that journey is going to lead us when we finally start finding things that we're like, well, is this maybe? I don't know. And it's going to get weird.
Well, it's going to be like, John Butler Burke looking at these radiobes, as he called them, these radium like creatures that he thought he had created, and looking at them through a microscope and saying like, I think these are alive. Like it's risky. It's risky. And, so there could be some real, embarrassing claims of life or something like life that turn out to be wrong because it's tricky terrain.
Yeah. Well, speaking of the ways that our lives have all sort of been interrupted this last year, I know you were working on this book long before the pandemic hit, and you get to travel a fair bit when you're working on these books. And so I must say, I'm stuck at home reading this book. I was a little jealous of all the places you got to go. And sort of from a meta perspective, as a science writer and author, like how has the pandemic affected your ability to keep working on stuff?
Well, it was definitely a challenge in a lot of different ways. I was just through pure luck. I had been doing traveling before for the book. I'd actually just finished hanging out inside an abandoned graphite mine in the Adirondacks, looking at hibernating bats in the middle of winter with some biologists. Right after that, everything shut down, and I just said,
thanks to a bat, ironically.
Yeah, exactly. And I just thought, I think that's the last trip for this book. And fortunately, I was able to sort of use the material I had and make lots of calls and Zooms and whatnot to sort of fill in the rest of the stuff. I think in a way it was actually good because it made me like sort of resist the urge to say like, oh, but I also have to talk about that, and oh, I have to go to Michigan and talk to this person. Like, no, what you've got is enough. You're good. And so, and then also on top of that, the coronavirus itself is a fantastic demonstration of the paradox of life. Is this thing that's turning our lives upside down, is it itself alive? And scientists have been arguing for about a century whether viruses are alive or not. So I was able to sort of work the pandemic into the book itself. But yeah, like as I was sort of winding down working on the book, I was ramping up helping with the New York Times and their pandemic science coverage, which has just turned into a complete hurricane of news. I'm actually taking a couple of weeks off just to like talk about the book and otherwise just sort of clear my head a bit, because it's just been, just so intense, like sometimes writing 2 or 3 stories in a day. And there's still more news to be doing when I jump back in. But here's hoping that there will be a chance to go and travel for reporting again before too long, maybe in a few months.
Well, this is hardly the most important bit of news, but you mentioning that, the Bat Cave trip was the last one you took before the pandemic hit just reminded me of the fact that like they're filming. I'm also a comic book nerd in my secret identity life. They're filming the Batman movie right now with Robert Pattinson starring as Batman, and they had to shut down production because Robert Pattinson got COVID. And so I'm like, they had to shut down a movie about Batman because the man playing the Batman got sick from a bat.
It's just too on the nose.
I know, right? Well, as long as it's not white nose, right?
Yeah.
Then you're okay.
Exactly.
So Sort of last question I have for you before we wrap things up. The publisher actually sent me an extra copy of the book, so I thought it would be fun if we did a giveaway to our listeners. Is there like a question we can get folks to answer, or do you want folks to like submit a story about, life that was important to them? Like what can we do to sort of ask folks to submit something that we can then pick a winner from?
How about what do they think is the weirdest form of life?
Weirdest form of life. Okay, so folks, either go to the contact page on our website, sciencesortof.com, I think /contact, but double check that because that might not be the right link. But I'll put a link to our contact page in the show notes for this episode. You can also email us at PaleoPOWs@sciencesortof.com. Carl, we're going to link to your book as well in the show notes for this episode. We've also become an affiliate with bookshop.org, which partners with local bookstores to send out books to folks in their community, which is a great way to get books like yours out there. So we will have your book available on bookshop.org/shop. I can never say it. It's too many slashes and S's. bookshop.org/shop/science sort of. So folks can go there if they would like to pick up a copy of the book, or, wherever fine books are sold. Where can folks connect with you on the internet, Carl? I know you're on Twitter and obviously writing a bunch for the New York Times, but is there anywhere else you want people to go to connect with you and your work?
My main website is carlzimmer.com, just my name. And on Twitter, I'm also Carl Zimmer. So those are the two places you can usually find me.
Awesome. Well, thank you so much for coming on the show to talk to us about your book today. I really appreciate your time, and I had a great time chatting with you.
Thanks a lot. It was a lot of fun. Thanks so much for having me.
All right. Well, thanks again to Carl for giving us some of his time. His books are so readable and legitimately a page turner. Like, you wouldn't think that a book sort of as heady and big picture as Life's Edge would be such an easy read, but it really is. And I encourage everyone to go check it out. And Patrick, you know where they can get that book from? This is important.
Bookshop.org? Is that it?
Yeah. But they got to go to a specific part of bookshop.org.
Well, lay it on us. What part?
Bookshop.org/shop/science sort of. That's our shop within bookshop.org where they can buy this book. They can buy other books too. You heard of Soonish? That's a book. You can buy it there. So yeah, folks are interested in checking out the book. We encourage folks to go to bookshop.org or buy it from a local bookstore if they can, or get it from the library. Libraries are great. And any way you choose to get it, I hope you enjoy it, and glad Carl was able to come on and talk to us about it. Now, we ended the interview with a challenge to our listeners, Patrick, because I got sent an extra review copy. And so I wanted to do a giveaway. And just to remind folks, Carl asked us to have listeners submit what their oddest example of life is. So I say we're going to probably let this go for 2 or 3 episodes for folks to get their replies in, and then we're going to reconvene. We're going to go over some of those answers, and we're going to pick a winner to send the book to, and that winner will be picked in our final segment of the show, which is coming up right now, and it's called the PaleoPOW. PaleoPOW is the final segment of the show where we delight in feedback from our listeners. Patrick, I'm going to ask you to go first and talk about Spy Kids.
Okay, so there's an email from Jeff S. And Jeff S., I don't know if he still listens, but he was one of our first listeners who really communicated with us a lot. So
always good to hear from Jeff.
Yeah. The subject of the email is Spy Kids 3D.
Yeah, at one point in an episode we had said that like 3D isn't usually utilized as a part of the story of movies. It's just like an added on sort of, ooh, look at this, it's coming right at you.
You're right.
Yeah, so this is in response to that.
So Jeff's thoughts are, Spy Kids 3D was a movie which had 3D as an integral part of the story. There was the real world and there was a video game world. where Sylvester Stallone lived. He was trying to get out, and the Spy Kids went in to stop him. The real world was regular movie, while the video game was in 3D. That's what's up, punks. Well, so that's sort of the Wizard of Oz approach to 3D, I guess.
Yeah, where you've got two different realms and you differentiate the realm based on either color or black and white or 3D or 2D. Yeah, that makes sense. I mean, the Matrix, famously, all the scenes in the Matrix have a slight green tint and all the scenes in the real world have a slight blue tint. It's sort of similar thing. So what do you think, Patrick? Do you buy this as an example? Have you seen, how familiar are you with the Spy Kids films?
So I'm relatively familiar with the Spy Kids franchise. I don't think I've seen Spy Kids 3D. And if I had, I certainly haven't seen it in 3D. But yeah, for a little while, my kids were sort of into Spy Kids. They were. I guess the thing I think about it most is that Taylor Lautner, is that right? No, that was Shark Boy and Lava Girl. Never mind. I don't know much about Spy Kids.
I thought Shark Boy and Lava Girl were part of the Spy Kids universe. Are they not?
I don't think so.
Okay. I don't know.
I don't know either.
But
not for sure. I don't think they are.
In terms of 3D experiences, I've learned from you that you've recently invested in some 3D simulation technology.
I mean, I have the whatever, the VR headset adaptation thing for the PS4.
So has there been anything that where like 3D, having the headset on was integral to the game you were playing or the experience you were having? Like, what's it been like having access to that technology in the home? I haven't invested yet. So
the most interesting thing, I guess, is just the ability to look around, right? I mean, so rather than, I mean, I did feel like so I'm playing Ghost of Tsushima, not in VR, but normally. But after having played with the VR headset on, you feel like your vision is restricted, like you're wearing a hat or a hood or something.
Okay.
You've lost your peripheral vision. So any of the other sort of tricks of like things coming at you or, the usual sort of 3D tropes, I didn't get a lot out of, but the sort of being able to look around your space as if it were real is kind of intriguing and interesting and sort of makes for the best experiences. I think I told you that maybe one of the more interesting things is a disc that the headset ships with, or at least ours did, that just has some just sort of like trailer type things on it. And one of the things is a shark dive experience where the shark is attacking the dive cage. And there's not really, I don't think you even use a controller. I don't think you push buttons. You just sort of look around while this is happening. And so it's less of a game and more of like a Disney ride.
What kind of shark?
What do you think?
guessing it was a great white, but I thought maybe they would have fun with it. Give you a giant.
It was a basking shark. No.
Goblin shark. Those are cool. That's a cool kind of shark. I mean, there's like 400 kinds of shark, Patrick.
Yeah, there are.
That's just extant too. There's probably even more in the fossil record. Probably. There's no way of knowing.
This might have been an extinct one. It's probably a megalodon.
That's a species name. You're not supposed to refer to fossil taxa by their species epithet alone, Patrick. Did you see that when the movie was coming out, Megalodon, everyone was capitalizing the M so that it would be the genera name for a thing called Megalodon, which is already a type of clam.
Oh.
So people were updating the movie poster with a giant clam instead of a giant shark, because if it's Megalodon the shark, then the M is the species name and it should be lowercase, right?
You mean the species epithet?
Yes. Yeah. On the binomial nomenclature system. Hey, what if we had a question about taxonomy and we could transition?
Okay.
Yeah, I've only just to follow up on your headset. I have worn a VR headset once, and I didn't get to play a game or anything. I had like a little paintbrush studio thing. I could like climb through a window, and it was in a space where I could actually like physically walk around too, and that was pretty cool. Mm-hmm. I had fun with that, but I have yet to like spend much time exploring the space in terms of what can be done with that technology. And like, I know that they've ported games that I really enjoy, like Skyrim, to a VR experience, and I could see myself enjoying that, but I also like, do I have 200 hours to spend back in Skyrim? not anytime soon. So I don't really know when I'm going to take the...
It also really takes you out of the room, right? I mean, not that video games are the most sort of social thing you could be doing, but you can sort of like if you're not concentrating too hard, you can kind of still be present in the room. If you put that thing on, man, you're gone.
Yeah. You almost need a separate room of the house for it. Like some sort of dreamatorium. Well, I also have an email that I want to, from a frequent listener and contributor, Bob M., who writes on the subject of taxonomy. And he says, I was listening to another podcast, the Strange Animals podcast, where they mentioned the Paraceratherium. Are you familiar with this animal, Patrick?
Kind of, yeah, like a giant mammal.
I think it's closely related to the Indricotherium, or are those the same? Is that the same animal and just two different names?
I'm assuming it's not the same animal, but
no, I think it is.
No, yeah, I think it might be Indricotheridae. Yeah.
So yeah, potentially the largest terrestrial mammal ever, giant rhino. Functionally, I don't know if it's actually within the rhino family, but rhino-like animal without a horn. Anyway, Bob continues, and I wondered if it was related to the vaguely rhino-shaped animal you were talking about in your latest episode. So that group of animals were notoungulates, I remember from that conversation with Robin. And a quick check on Wikipedia shows that notoungulates are a different order, so probably not closely related. But can we qualify that any further? I rapidly get lost in technical terminology. Is there a good resource that would help a layperson understand evolutionary relationships between different groups of animals? Which I thought was a really good question. So, yeah. Patrick, what do you know about ungulates? I know you were a reptile guy back in the day, but I know you probably had to go through some mammal training.
Yeah, to some degree. Yeah, I mean, ungulates, they're big mammals with hooves. We split them into even and odd-toed ungulates. So the odd-toed ungulates, like horses, and rhinos are in there as well. And then the even-toed ungulates are sort of the other domestic animals, are like
camels,
pigs.
cows, pigs. Yeah.
Yeah.
And so I'm not an expert. Go ahead.
Also, like most of the ones we know and love, giraffes, deer, and even hippos are in the odd-toed ungulates. But go ahead.
Tapirs are even-toed ungulates. People love tapirs.
That's true. So there's another southern ungulate for you, I guess.
And odd-toed ungulates also include whales, so it gets a little wonky there. Basically, when you're talking about taxonomy at this level, essentially Linnaeus came up with this classification system that made a lot of sense in a pre-evolutionary worldview. So, his whole kingdom, phylum, class, order, family, genera, species. Did I get that right? He proposed this, and we started slotting animals into that, but we didn't really understand that there was this idea of common descent. So there wasn't a sense when Linnaeus came up with this, classification, this taxonomic classification system, that when we said that something was in kingdom Animalia, that was referring to all animals sharing a single common ancestor, some sort of, basal animal that existed at some point in the past of all animals. And we've done our best to sort of map that system onto how we now talk about animals in a more phylogenetic cladistic sense. And ungulates are sort of a funky one, because there's not really you can't really say class Mammalia and then you go straight to order, order Artiodactyla. And so you're missing out on some of the divergences that have happened there. So sometimes people will stick in levels in between those. So you'll see sometimes magna order or grand order or super order or mere order. And that's sort of like us trying to slot in some of these diversification points in this system that wasn't really built to have them. And so as far as we know, all ungulates fall within Epitheria. So that means kind of the not true mammals, I guess that would be eutherians, but Epitheria is we tend to put all the placental mammals that aren't sloths and their relatives are Epitherians, basically. Within Epitheria, we do believe that all ungulates, all hooved mammals, share a single common ancestor, so there was a divergence point at some point. The even-toed ungulates are one group, principally Perissodactyla is the main group that we think of within the even-toed, or the odd-toed ungulates, excuse me. And then Artiodactyla contains all the even-toed ungulates, and sometimes, because that group is now known to include whales, you'll sometimes see that written as Cete Artiodactyla to try to include the sort of cetacean side of things. I personally don't subscribe to rejiggering the taxonomy that way. way. I think it's fine to just call whales artiodactyls. I don't think you need to change what an artiodactyl is to make sure that it is inclusive of whales. That's just my personal, that's purely, sort of an aesthetic feeling that I have there. And then I don't think I did a good job of explaining this when we talked about it, Bob, so I'm glad you wrote in and asked about this. There is a separate group for the South American ungulates, including the notoungulates. And I know I said South American ungulates, which we mentioned includes tapirs, but we're talking about notoungulates being this separate sort of third branch on that sort of ungulate tree that is not inclusive of either, or not included in either artiodactyls or perissodactyls. Does that make sense, Patrick?
Yeah. It's a bit roundabout, but yeah, I get your.
Well, how would you explain it? I agree. This stuff
I think it's hard. It's hard to explain with no visual aids and no, So notoungulates are most closely related to what other ungulates, I guess, would be.
So from the stuff I've looked up, it is unclear if that's a polytomy or just poorly resolved right now in terms of where do notoungulates. I can't tell from the charts I'm looking at if they're more closely related to either of the extant groups of ungulates or if we're just not sure yet. So I can't answer that question.
Fair enough. You don't know. I mean, because we don't know all the time how everything is related to each other.
And then to answer Bob's second question, in terms of is there a good resource, I think there is a good resource, and it's called tolweb.org, treeoflifeweb.org. And it is a graphical representation of the diversity of life, complete with references and good pictures. And so you can kind of go... Have you ever used this website, Patrick?
Yes.
Yeah, it's pretty great. So it includes extinct groups as well. So a lot of these resources, it can be hard to figure out where sort of the extinct and extant groups kind of coalesce, and this does a pretty good job. It doesn't always have as much information about the extinct groups, but you can at least see where they map. And yeah, I recommend it for folks who are interested in sort of just clicking around, and you can sort of just click your way down a path and see where it takes you and see what animals or plants or fungi or even some single-celled life show up as you sort of work your way through the tree. So I think it's a very good resource if that's something that you're interested in exploring, Bob. I don't have like a good book or anything to recommend. I wish I did. Obviously, I pulled this email because I think that this book that we're talking about right now, Life's Edge, and the book we're talking about in our next episode are both good resources, but they're not exactly what you're asking for, Bob. But I think this tolweb.org is something you'll have a lot of fun with.
Cool. Yeah, I don't use this website that much anymore, but there was a period in my life where I was visiting it a lot.
It can be very helpful if you can't quite remember how things come together. Well, Patrick, thank you for joining me on this episode.
Yeah.
Glad we got a chance to catch up a little bit. If folks would like to hear more episodes like this, it is important that we have your support in this effort. It's not, it's not free. Our time's not free. The editing's not free. There's a lot of things that go into making even a relatively small podcast like ours run smoothly. And if you want to support us in that way, again, bookshop.org/shop/science sort of is a great way to support us while buying books that you are excited to read. But you can also go to our website, sciencesortof.com, for the show notes for this episode. We don't have any ads on that site, so we're not making any money that way, but that site will link you to places like PayPal, where if you want to give us a little bit of money one time, you can do that, or Patreon, where if you go to patreon.com/sciencesortof or click the link on our website, you can sign up to be a recurring Patreon donor at any level, and that goes a long way towards helping us pay for the show. So thanks to everyone who does that, past, present, and future. All right, I think that's all we got. You got anything, Patrick?
I don't have anything to add.
Great. Well, what you can add is the type of thing that people will get when they come back next week, because I can proclaim that they're going to get one kind of thing, but then you can add a modifier on that at the end, which is how we usually sign off. And so building to that, I will say, see you next time for a whole lot more science.
Sort of.
Audio production for Science Sort Of is done by Rob Heath at Rob Heath Studios. Thanks, Rob.
Visit sciencesortof.com for show notes, links to all the stories we talked about, and ways to interact with the hosts, guests, and other listeners. Science Sort Of is brought to you by the Brachiolobe Media Network of podcasts. That's all for this week. See you next time on Science Sort Of. I don't understand notoungulates. I just don't get what they are. I've
tried. They can't get it.
Right.
I mean, there's so many biologists and paleontologists that are obsessed with hoofed mammals. I'm just like, you know what? You can have them. It's fine.